Okay guys, today we're going to do 6G trig identities. There's quite a number of things involved, but let's do some quick revision first. So, with reciprocal identities, which we have already done before, in the last few exercises we've said, what's the reciprocal sign? What's the reciprocal sign?
Cosec.
Cosec. Let's write this down. Draw. So cosec theta is 1 over sine theta. So we call that reciprocal identity, right? Nothing new. Quick revision. What's the reciprocal of cos?
Sec.
Sec. Very good. Sec theta is 1 over cos. What's the reciprocal of tan?
Cot.
Cot. So very good. Quick revision. Obviously, bear in mind, sine theta can't equal to 0, tan theta can't equal to 0, cos theta can't equal to 0, right? Denominator cannot equal to 0. Okay, so we've done reciprocal identities. You guys have seen before. What we mean by ratio identities? What we mean by that is tan theta equal to sine theta over cos theta. Another way you can look at this is if we look at from the right angle triangle point of view, alright? That's theta, and we know tan theta is opposite of adjacent, rise over run, alright? The vertical is always the sine theta, horizontal is always the cos theta. That's how you look at from another perspective. All good? Tan theta is sine theta over cos theta, rise over run. So tan theta is this, cos theta is the reciprocal, cos theta over sine theta. All good? So today is heaps of identity, but I really don't want you guys to memorize this by heart. Reciprocal, rise over run, reciprocal again. Okay, one more. All of this we're revision so far, right? When we get to the new content, I'll slow down. The complementary angle identity. What does the word complementary mean? Okay?
90 degrees.
90 degrees. So 20, 70, 45, 45, 80, 10, etc. Because of that relationship, we have the following complementary angle identity available. So cos 90 minus theta is sine theta. Once again, if we put this into a right angle triangle, we can easily prove it. All right. As theta, let's say A, B, C, then it is 90 minus theta. So what's sine theta? Sine theta is
90 minus.
sine theta in this diagram is opposite over hypotenuse, right? Yes. So cos 90 minus theta is also B over C, adjacent over hypotenuse. That's why we say these two are the same. Yep. Again, I really don't want you to guys memorize this by heart, because if you try to do this, there'll be too many identities in this little exercise, and you will lose track of what's going on. Just remember the picture. Yeah? Okay, next one is cot 90 minus theta again is equal to tan theta. For exactly the same reason. Next one, cosec 90 minus theta is sec theta. That's what we mean by complementary angle identity. So all of this hopefully is nothing really new. The new stuff, I'm going to slow down now, is Pythagorean identity. The CO stands for the complementary cosine. CO.
Cool.
It's pretty cool, isn't it? So CO stands for
random words.
Yeah.
Oh.
Not really random words. So CO is sine, right? So CO SINE, that stands for the complementary of sine. That's why it's 20, 70, 80.
What's second?
10, etc.
It's on the camera. Oh, okay, that one. Yeah.
Alright. Okay, now I'm going to slow down. This part is brand new for this section now. Please write down this little title in your book. Pythagorean Identity. So from here, we're going to get in heaps of show that sort of question. We want to show, we want to prove, as well as simplify. Okay, let's have a look at this circle here. We call it a unit circle. So in the past, we said when we measure angle, we start from the positive x-axis and we go anti-clockwise. So when we do that, we've got angle theta available. You agree? We've got angle theta available. Now let's have a look at here. So how do we represent y? In order to do that, right? In order to do that, we say sine theta is y over 1. Do you agree?
Mm-hmm.
Therefore, y is sine theta. That's what I was trying to ask. How do we represent y? Y is sine theta. Yeah? How do we represent x? What's cos theta? Cos theta is adjacent over hypotenuse. So x is cos theta. And I put this into a right angle triangle. We say x squared plus y squared equals r squared. Pythagorean theorem, right? A squared plus b squared equals a squared. So let's write this down. X squared plus y squared equal to r squared. In this case, it's 1 squared. So x squared plus y squared equal to 1. What's x? X is cos theta. So therefore, it's cos squared theta. What's y? Y is sine theta. So sine squared theta equals 1. Now, normally we write down sine first, but doesn't really matter. So I'm just going to rewrite it. Sine squared theta plus cos squared theta equals 1. Then we finish the first identity. This is the most important, pretty popular, famous Pythagorean identity. That's where it comes from. Sine squared theta plus cos squared theta equals 1. Now this thing, after a while, should be in your head, but that's where it came from. Basically, that's where it came from. Okay, there are two more. This one, put it here. Basically, just really explain what I already said just now, right? Vertical is sine theta, horizontal is cos theta. That also explains that's where tan theta come from. Sine theta over cos theta. Fantastic, all good? Awesome. Okay, so this is the first one you guys need to know in terms of the 3 important trig identity in this particular exercise. Next one you need to know is, look at here. From this identity, right? If I'm going to divide both sides by sine squared theta, see what happens. So I'm going to write down divide both sides by sine squared theta. Oh. So what I mean by both sides, I mean every single term, right? So sine squared theta divided by sine squared theta is 1. Let's write down. So 1. Now cos squared theta divided by sine squared theta. What's cos over sine?
Tan.
Cos over sine.
Cos.
Cos, yeah. So square, you just have to write down cos square theta. Now 1 divided by sine is
1 over sine.
1 over sine is
Cosec.
cosec. So it's cosec square theta.
Whoa.
Can we write this down in your book now? That's the second important identity. Now they all come from the first one. That's one. The first one is the most fundamental, basic one. We must almost remember it by heart, and it's not hard to remember, right? Now, second one done. Third one is we're going to divide both sides by cos square theta. See what happened this time. So divide both sides by cos square theta. Now let's have a look. What's sine square theta divided by cos square theta?
An amount.
Oh, sine over cos is
10, so it's tan square theta, right? All good?
Yeah.
Yeah.
Awesome. So tan square theta.
Wait, where's sine?
Oh, we're going from one.
From the first equation.
From the
Oh, from
Sine
the
squared.
first equation.
Yeah.
Yeah. Then cos square theta divided by cos square theta?
1.
1. What's 1 divided by cos?
K sec.
Sec. So it's sec square theta. Finish. 1, 2, 3. These are the very important 3 Pythagorean identity. Well, the first one is the most important one, right? Now, I must say that this is what I mean. There will be heaps of identity, and later on, when you guys move into extension 1, next year will be double angle, all that. So it'll be more. So I do not want you guys to memorize every single thing by heart. If you do want to remember, just remember the first one. These two you can, as what I did, you can derive within 30 seconds, right? Divided by sine square theta, done. Divided by cos square theta, done. Okay, very good. Now, heaps of example I'm going to show, and we'll finish for today. Now, as you can see, there are heaps of example here. Let's do it one by one, right? I'm going to write down all the solutions on one note, so when people come back, they can just refer to the referencing here. Hopefully I do have enough space. So, question 1. Question 1. It says, fully simplify. Notice that I put some of simplified question first, and all the rest is proof or show that sort of thing. Okay? Let's have a look. Fully simplify 1 minus this minus that. So what I'm going to do is I'm going to write down, I'm just going to copy down 1, take away cos square theta plus the, have a think, what's cosec square theta? Then go back to use the identity we've just shown here.
Cos over 1.
Here. What's cos square theta? 1 plus cos square theta.
Oh.
So this part is going to be replaced by those two terms. Put it in here. Cool? Okay, so because we are beginners, right? So I suggest you keep these two and these today and next few days on the next page or the question next to you so you know what you're referring to. Cool? Okay, so cos square theta is 1 plus cos square theta. And obviously these two cancel, so the answer is 2.
No.
My brain. Oh yeah, it is.
All I have done is connect like terms.
Yeah.
Okay? Yes?
Yeah.
Good.
I'm still stuck for some reason.
Like terms. Positive, negative, 0.
Yeah, but we replaced cosec.
No, because in the first equation we.
Oh
did
yeah,
that.
sorry, yeah.
Yeah, all good. No worries.
Oh yeah.
Are people ready for me to move on to question 2? Is question 1 okay?
Yep.
Mm-hmm.
Question 1 all good?
Yes.
Okay, all good. Question 2, let's have a look. Fully simplify this. Alright. So, make it a little bit bigger so you guys can see. Question 2 is this one. Fully simplify this minus this. Now, usually with this sort of thing, I'm going to start from the basic definition. What's cot?
Correct. 10 over
Yeah.
1.
So 1 over 10.
1 over 10.
But what's the definition of cot?
Reciprocal.
Okay.
Cos
Cos over
zero.
sine.
Oh.
Right? Cot is cos over
Oh,
sine.
okay.
So I'm going to go from there. If it's square, I'm just going to square both top and bottom. Yeah? So let's write down question 2.
Oh, the other one's that.
So question 2, cot square theta becomes You agree with that?
It's just cos minus 1. Cos squared.
Hold on. This term, you guys are okay with that? This basically just become this. Alright, I'm going to start from the basic definition of chord. Chord is cos over sine, square and just square both top and bottom. Second one, copy down. From here, it becomes basic algebra. Denominator is the same, I keep the denominator, I subtract the top.
Okay.
Boom.
Do we agree?
Yep.
Do we agree? So far so good? What is on the top? Cos squared theta minus 1. Sounds like difference of 2 squared, isn't it? It's a plus b times a minus b business. Yeah? So let's keep going. So which is
Keeps going.
actually not yet, sorry. My bad. I'm just going to write down down the bottom. What's sine squared theta? Sine squared theta is 1 minus cos squared theta.
Okay. Oh, yeah, it is.
From the most famous one we keep saying today.
That's my
Yeah?
Yeah.
What's sine squared theta? Sine squared theta is 1 minus this.
Yeah. Oh, yeah.
Okay, on the top, copy down. I hope at this stage people notice that these two are so similar,
Yeah.
just a negative sign difference. So what do I do? I take the negative out, top and bottom cancel, finish, the answer is negative 1. All you are doing is factorize.
You show.
Down the bottom is a year 9 technique, down the bottom, there,
What, multiply it by minus 1?
you take the negative 1 out, then you have cos squared theta minus 1. On the top, you just copy down, top and bottom cancel, the answer is negative 1. Then you finish. All I have done is take the negative 1, take the negative sign down the bottom, take it out. Right? That technique is you guys did in year 9, factorize.
Yep.
The top and bottom cancel, then you're done. All good? Sorry about the space here. Question 3. So pretty much all the question examples I put here, for the rest is show that. All right. So when it comes to show that question, particularly in the HCC, I do want to address that we cannot assume at this stage that the left hand side equals the right hand side. At this stage, we don't know. Otherwise, what's the point of showing, right? So we have to start from one side, usually on the left hand side. We do the simplify, and hopefully we do get it right. Then equal to the right hand side. Yeah. Some questions require, okay, we start from left hand side. I go somewhere in the middle. I can't go anymore. Then I start from right hand side. Then they combine. Oh, they equal. Okay. So let's have a look. Question 3. Question 3, sine theta. What's sine theta? So sine theta, copy down. What's cos theta? Cos is cos over sine. You agree?
Yeah.
Sine and copy down. What's cos? Cos is cos over sine.
Yeah.
Then obviously sine and sine cancel. Once they cancel, what's on the right hand side? Bingo. Yeah?
That's crazy.
Crazy. So it's cos theta, then I say equal to right hand side. Then you can go like that, then drop down. In other words, it's proved.
Yeah.
All good?
Ah, yeah, because it's just cos equals cos.
Yeah, that's what you're trying to show.
Cos theta equals cos theta. And then we can simplify what we can say theta equals theta.
Alrighty.
Wow.
Alrighty, let's have a look at question Question 4 is almost as, sorry, yes, question 4 is almost as the previous question, right? Almost same thing, just one more practice. Cos A in this case obviously stands for an angle, so I'm just going to write down cos A, right? Now what's tan? What's tan?
Tan.
Sine over cos.
Sine over-
Beautiful, well done. Now, you can see cos and cos cancel, so the answer is sine A equal to right hand side. I just put question 4 there for practice one more time basically, but similar sort of thing. Question 5. Now question 5 looks hard, but actually very easy, right? Let's have a look. Sine squared theta plus cos squared theta, straight away that becomes 1. Can we say that?
Yeah.
So handy, right? Guys, come on. Straight away that becomes 1. I'm already moving on to question 5.
Wait, what?
That's 1 over cos, which is the reciprocal.
Fantastic. Matthew, well done. Okay, so sine squared theta plus cos squared theta on the top using our famous identity on the top already becomes 1. And the 1 over cos, sec theta, done.
Oh, that's pretty good.
That's right, number 5 looks hard, but the
Yeah.
actual line working out, just one step.
Oh yeah, 1 over cos.
Alright? All good?
Yeah.
We go into 6.
Next one. Number 6 here. I'm going to skip a few, but now I'm going to do a little bit harder ones after this. So question 6, let's have a look at first. How about this one? We start from the right hand side. So 1 plus this. The reason I start from right hand side is I want to change cosec. I want to change the unusual ones. Okay, sine cos tan, we're very, very familiar with. We want to change the reciprocal ones, right? So what's cosec?
1 over sine.
Very good. 1 plus 1 over sine alpha. 1 plus 1 sine alpha. Here, you notice, you can almost think like this, right? I got the sort of like integer, I got a fraction. Straight away I'm thinking about common denominator. Yeah? I'm thinking about common denominator when I have a situation like this. Then, what's common denominator? Sine alpha. Now on top it's just sine alpha plus 1. From here is not trigonometry, from here is basic algebra now, right? Now what's on the left hand side? Look here. Then you got this now, you got sine alpha, on the top you got sine alpha plus 1. What's on the left hand side? Exactly the same thing, isn't it?
Yeah.
Already job already done. And yet, therefore you say equals left hand side. Beauty. Can I skip a few? I'm going to do number, in this case, I think it's your number 9. Question 9.
Question 9.
This one here. This one got a few things involved. I got a sine, I got a cos, I got a cot, I got cosec. Quite a number of things involved, right? But don't worry, and just start from the basic trig definition for each of them. Okay, let's start one by one. Sine alpha, copy down. Sine alpha plus cos alpha, copy down. Okay, what's cot?
10 over 1. 1 over
What's
sine.
cot? Cos over sine, right?
Yeah, cos over sine.
So cos over sine alpha, copy down like that. Then do you agree that that I'm going to do common denominator now?
Yeah.
Here I don't have denominator. Here I've got sine alpha. Therefore, common denominator is sine alpha. Is sine alpha. I've multiplied by sine. I've put sine alpha here. This one has to be sine square alpha. Right?
Mm-hmm.
Yes? No? Common denominator. It's
Oh,
common
yes.
denominator.
Yeah,
It's
yeah, yeah.
fraction with
Yeah,
different
yeah,
denominators.
yeah.
Well done.
Sine squared.
That's
Cos squared
sine
alpha.
square alpha plus cos square alpha equals
This is
1
so cool.
1 over sine alpha. What's 1 over sine alpha?
Cosec.
Cosec.
It's
Cosec
just like
alpha,
maths, but with letters.
which is the right hand side, and we proved. But from here to here, you just grab common denominators for different fractions. You can think like
So
that.
what's cos? What's tan? Yeah, cos of the sine, so right, times cos of the sine, yeah?
I don't really get it, but I'll figure it out.
Yeah, I'll come to help you after this, right?
How does
Right, so
sine,
you can times these together, right?
like the first step go to the second step?
Okay.
I
All I'm doing is just think about this as the integer. I know it's ratio, trig ratio, right? Think about it. I got an integer, I got a fraction. How do you do this?
Get to sine squared x over sine
It's
x.
the same thing.
Ah.
That's all I have done.
Sine squared and sine.
That's all I have done.
Yeah, that's
okay.
And
Yeah.
then you can add it onto there.
Yeah, I guess.
Different concept, different context, same principle. That's all I've done here. I put 3 as a common denominator. I put a sine alpha as a
Now
common
times
denominator.
these together and like.
All good?
Yeah.
Awesome.
Yeah, this is false.
Okay. Right.
That's a false, yeah.
Next thing I want to talk about is number
Because these two times together.
number 11 here. Prove that.
Oh, yeah.
Yeah.
Prove that. So let's have a try.
Sin squared x plus cos squared x over sine.
Alright guys, can we focus on this one? It's our last one. I want to show us an example.
And then sine
Then you guys
squared
got plenty of time to practice.
2. Which is 2.
Guys, come on. Just let me finish this one. Then we'll have plenty of time to practice. Then I'll walk around to answer individual questions. So for now, let's have a look at the question 11. Cot is cos x over sine x. Tan is sine x over cos x. Yeah, I change cot to this, tan into that. Then I found, oh, denominator is sine, denominator is cos. I cannot add two fractional denominators different. What is it? Common denominator. So sine x, cos x. For this fraction, I've times by cos x. On the top, I must also times by cos x. Cos x times cos x, cos square x. The exactly same reason that's sine square x. Therefore, on the top becomes 1 sine x cos x. Now, this question is a little bit harder than the ones we did just now. Look here. For this one, I cannot simplify anymore. I get 1 over sine x cos x. Right? I say, oh, that's not the right hand side yet. But have a look. What is the right hand side? Right hand side is cosec and sec. Right? Well, which is pretty much the same thing. So if you have a look at the right hand side, sorry about the space here. Right hand side in this question is cosec x, and sec x is actually 1 over sine x times 1 over cos x. That's the definition of those reciprocal functions. Therefore, is 1 over sine x and cos x. So when these two are the same,
We said drop down, put.
This question, this is what I mean. I go from left hand side, I go here, I can't go anymore. Then have a look at what is my right hand side. Right hand side is this. I do the right hand side, therefore suddenly they are the same. Then we can say yes, we have showed left hand side does equal to the right hand side question.
Surely you could have just continued with the left hand side. and
Yeah,
say-
I could do that as well, correct. Yep, I could do that
It's
as well.
easier to go with the
Yeah,
left
yeah,
hand
yeah.
side.
Yep, cool. Awesome.